show you guys the answer key to tutorial 4. Okay, so instead of giving you the final one answer on all of these problems, I want to take you guys through the steps on how you should be working out. Okay, so if there is a problem that you don't understand in the future, you can always come back and look at this video and see how each problem is being worked out. Okay, so I'm going to put the timer in the video as well, so that when you're taking an exam or a tutorial, right, you should know how much amount of time you're spending on each problem and how much amount of time that you have left, okay, for the remainder of your problems. Okay, so let's start with question number 1. So radium-226 can be represented by using the symbol 226R888. Now the question asks us to state the number of protons, electrons, and neutrons in a radium atom. Okay, so this is a very simple question. This is also coming from your chemistry knowledge as well. Okay, so number of protons, let's do this. Okay, so all right, number of protons is your mass number, which is on the bottom left. Okay, so it's 88, so your number of protons is 88. All right, electrons, let's see. So your number of electrons is always equals to your number of protons, because an atom is always electrically neutral, so that's why your electrons is also 88. And finally, they ask you about neutrons. So for neutrons is always mass number minus your atomic number. Right, so your mass number is 226, your atomic number is 88. Okay, so 226 minus 88, let me get my calculator first. So you should get 138. Alright, so for this you will get 1 mark. For this, you will get 1 mark, and for neutrons, you will get 1 mark. Right. Now, this is fairly simple, so let's do number 2. Now, for a scientific investigation, a student records the volt and current data of a lamp for 30 seconds. Alright, so let's see. So they give us voltage, current. So they're asking us to find power and energy. So what information do we still get, or like can we still get from the question? So you must always read the question carefully so that you can extract all the information that is given to you. Right now, for a scientific investigation, that is just an introduction to the problem. A student records the volt and current, okay, volt and current for a lamp of 30 seconds, okay? So instead of just putting your question under here, they try to make it like not invisible, okay, so that you might skip over it. So the first question is, state the unit of power and energy. Okay, so power, the unit of power is fairly simple. Okay, for A1, power is just W-A-T-T watt, and the symbol for it is W, and energy is E-N-E-R-G-Y. Energy is J-O-U-L-E, joule. Okay, so like in exam, right, for physics, they usually, or like they would normally ask these sort of questions on where they ask you, okay, state the unit of power, state the unit of speed, acceleration. When they ask you these problems, you should be able to get all of these right, because these are very easy and you should be able to put those marks in your bag. Okay, right, so you get 1 for each, 1 for each. Now copy the table and calculate the missing value of power and watt. So let's do this one, P. So what formula are we going to use for power? So I'm just going to write down here, okay? So power is equals to voltage into current, or you might remember this as P is equals to VI. So V is 2, I is 0.4, so P is equals to VI. This is 0.8, this is 3.6, and this is 9.6. okay, so you're just going to multiply these. Alright, how about energy? Now, energy is still the same. So if you want to calculate energy, energy is represented by E. So E is equals to, what's the formula that you know or you can use here? It's VIT. So where does this T come from? This T comes from 30 seconds. Make sure that you have your units right, okay? If it's like minutes or hours, you have to convert this, okay? In physics, you really have to be careful about your units. So let's just say 0.8 into 30. This is, VI, okay, 24. Okay, this is 2.6 into 30. This is 108. And this is 9.6 into 30. So this is 288. All right. Okay, so the unit of power is all watts, right? So you put watts here, watts here, watts here. The unit of energy is joules, joules, and joules. So in exam, whether they ask you or not, if your physical property has a unit such as meters per second squared, always make sure that you are putting the units besides your value for your numerical values, okay? All right, that being said, let's go to another problem. So this question is about voltage and current, and the diagram shows two resistors connected to a battery. This is the how would I say this? This is one of the most simple circuit diagrams that you're going to be seeing. So you should be able to solve this after you have done your unit to electricity. Calculate the voltage across resistor R. So we want to know the voltage across here. So what is given to us? Okay, let's write down what is actually given to us first. So the total voltage VT is 9.2 volt. What is the current? I is equals to 12 milliamperes. So what you should know here is this thing, milliamperes. Okay, if you are careless, you accidentally skip over milli, then you're not gonna get this 4 marks. Okay, so if it is milliamperes, convert it to amperes already. Okay, 0.012 amperes. All right, so we know the current, we know the total voltage, we know one of the resistance. Okay, we're trying to find this. All right. So let's find the total resistance first. Okay, so total resistance, let me symbolize it as RT is equals to 240 plus R. Okay, so total voltage VT is equals to I into RT. So VT is how much? 9.2. Current is 0.012, and RT is how much? 240 plus R. Okay, 240 plus R. So let me do some calculations. 240 plus R is what? 9.2 divided by 0.012. 766.67. What is our R? Sorry, minus 240, so 26. Now, just because you have done a good job finding the resistance, you can't stop here, because what is the question asking? Calculate the voltage. I noticed that some of you make a mistake of stopping right here. It's just a waste of marks. You know how to find this, right? So always read the question very carefully. So calculate the voltage across resistor R. So we're trying to find VR is equals to current into the resistance. So do we know the current? Yes, 12 amperes, because since this is a series, the current is going to be same throughout the circuit. Okay, so this is 0.012 into, what is our resistance? 526.67. So how much do we get? 0.012 into 526.67. So it's going to be around 6.32 volt. I'll be done. Okay, all right. So you should be able to do this, okay? Because you might be you won't get a small simple circuit symbol than this. Okay, you're only going to be seeing a lot harder where the resistors are parallel, the parallel resistors are connected in series. Okay, so this is the basics that you have to be able to do. All right, now this is going to be slightly harder. Okay, so let's read the question first. A 12-volt battery is connected to a component X and a fixed resistor R as shown. So we've got a 12-volt battery here. We've got a resistor and a component connected in parallels. We've got 1 ammeter, 2 ammeter, 3 ammeters. All right. First thing is take the name of the component X. So by looking at this component X, you should be able to tell what device it is. Okay, is it a bulb? Is it an LDR? Okay, so yeah, so it's already in the textbook. So in exam, this is also very commonly asked question. Okay, so state the name of component X. This is a light dependent resistor, so it's LDR, or if you want to write it in long form, it's okay. All right, so for this, you get 1 mark. So draw a voltmeter on the circuit diagram connected to show the voltage of component X. So on this diagram, they are asking you to draw a component, okay, or a voltmeter. Okay, so now they're even mentioning that draw a voltmeter. It's not just any device, it's a voltmeter. Then you know that voltmeter is always connected in parallel to the component of the circuit that we want to measure. Okay, so how you're gonna draw is simple. Alright, so that's 1 mark for you. Very easy, right? So the voltage across component X is 12 volt. Okay, so the voltage across this component X is 12 volt. But the voltage across component X is 12, although they are mentioning that, right? You should know that the voltage is the same as here, here, and here. Why? Because they are connected in parallel to each other. But let's just continue with the question. The voltage across component X is 12 volt. The resistor R has a value of 840 ohms. Show that the current in ammeter A1 is approximately equals to 0.018. So they have already given you the final answer. You just have to prove it, and they are even giving you the formula that you should be using. Okay, which is voltage is equals to current into resistance. So let's do this. So simple. V is equals to IR, right? And we want the current, so we try to change this equation. I is equals to V over R. Okay, so which one are we trying to measure? In A1, okay, which is here. All right, so it's V1 over, I would say, R1. Okay, let's just say this is R1. So V1 is how much? The voltage across component X is 12 volts, so you know that this is 12. And R1 is how much? 840 ohms. So this is 12 over 840. 12 divided by 840, you get 0.014. So 4, if you do it mathematically, you know that it's 0.01 amperes. All right. So when the circuit is placed in daylight, the current in A2 is 0.011 amperes. Since this is a light dependent resistor, we're going to be placing it in light rooms and then dark rooms. Hope it out. Okay, so the current in A2, we know the current in A2, they give it to us. Now they're asking us what's the current in A3. So the current that flowed through here, the I1 is going to be here, and the current that flowed through A3 is going to be here. Okay, so since they are combined here, we just have to add it up in order to get A3. So which is I3? Let's just say this is I3. I3 is equals to I1 plus I2. The one that we found in B is our I1. So I1 is how much? 0.01 amperes plus I2 is how much? 0.011 amperes. So how much do we get? 0.021 amperes easily. Okay, this is another mark. All right, I think I forgot to mention here. Yeah, so you would get 1 mark for changing the equation. You would get 1 mark for your correct final answer. All right, so the last question, which is a very common question. Okay, explain what happens to the current through A3 when the circuit is placed in a darkened room. So for these special resistors, right? For these special resistor, what's a common question to ask is, okay, what happens when you put it in a dark room, when you put it in a light room? If it is a thermal dependent resistor, what they're going to ask is that if you put it in a hot room, what's going to happen to the current? If you put it in a cold room, what's going to happen to the current? Okay, so those are very common questions. But let's try to answer this for now. Okay, all right. So when our room is dark, right? So when our room is dark, because of the resistance of LDR will increase, because in a dark room the resistance will increase, meaning that the current in A3 will also decrease. So what most of you will do is answer until up to the point where the resistance will become lower. You're right, but they're not asking you about the resistance. They're asking you about the current. What you can answer is alright, as the room darkens, right, what's going to happen is the resistance of your LDR will increase. Since the resistance will increase, what's the explanation that we want? Current, right? So the current in A3 will decrease. So any explanation along the line where it says resistance of LDR will increase, 1 mark. Current in A3 will decrease, 1 mark. Okay, so that's 2 marks for you. All right, you should be able to answer this. Okay. All right. All right. So another question asks us: the diagram shows a simplified view of part of an inkjet printer. Okay, so a negatively charged ink falls vertically between a pair of charged plates. Okay, so this is a simplified view of an inkjet printer. So we're going to drop this negatively charged ink between the negatively charged plate and the positively charged plate. So what it says is that the ink drop experiences a horizontal electrostatic force, acid force. So it's going to experience an electrostatic force. Of course, it's negative and positive. There will be an electric field, and it's going to feel it. Okay, it's going to experience it. So you have to explain the direction of the electrostatic force exerted on the ink by the charged plates. So if you are not familiar with an inkjet printer, you can always do reasoning. Okay, this is a negatively charged plate. This is a positively charged plate. So you know that the opposite charges tend to attract to each other. So that is why this negative charge is going to be attracted to the positive charge. So since it says explain, right, we have to say where it's going first. So it's going to the right side. You can say that it's right side, or you can say that it's towards the positively charged plate. Okay, any answer would be correct. You get 1 mark for it. But in order to get complete 2 marks, what you have to answer is why? Because opposite charges attract each other. Alright, now your answer is complete and you're getting 2 complete marks. Alright, so on the diagram, draw the path of the ink drop as it falls between the charged plates until it hits the paper. So on the diagram, it says draw the path of the ink as it falls between the charged plate until it hits the paper. So how it will look like is, this is not a magnet sort of thing where it's like boom. Okay, so it's not a magnet sort of thing. So what's going to happen is it's going to fall in a curved line, okay, until it hits the paper. All right, so if you draw that, you already got 2 marks from here. Okay, all right. last question, number C. Explain how another ink drop could be deflected in the opposite direction by a greater distance using the charge placed in the inkjet printer. So when you see a long question like this, try to focus on what they're trying to ask. So first, they want you to explain. Okay, you know that they're trying to ask you to explain how another ink drop. We're going to drop another ink drop, but this time we want it to be where? Opposite direction. So that's the first requirement. They want us in the opposite direction, and the second part is by a greater distance. So there are two parts to this question. So they ask us what should we do, what changes should we do if we try to make it in the opposite direction and by a greater distance. So in order for it to move it, if we're curving to the right, if we want to curve it to the left, which is the opposite direction, we can change the polarity of the blades, meaning that we can switch, okay, or we can switch the blades actually. So, oh my god, my hair. For opposite directions, right? Switch the positive and negative, so switch the polarities of the plates. And for a greater distance. So what's going to make a charge move further and further away or pull in from a great distance? What value can we increase? We can increase the charge on each plate. Okay, so try to use reasoning in order to answer it. Although these questions are not something that you have seen before in your exam or practices, you must be able to use your knowledge and do reasoning, and you will be able to answer these questions. All right. Okay, so for greater distance, you can increase on the plates. So from here, you'll get 1 mark for opposite direction. You'll get another mark for greater distance. All right. I hope you guys can answer this. All right. Okay, number 6. This is our last question, I think. Okay. Lightning strikes. Alright, let me see where my paper is. Alright. Lightning strikes the earth frequently and often starts in rain clouds. Now, inside the clouds, powerful winds, they move ice particles in tiny water droplets. So ice particles and water droplets, they are particles in the clouds, right? So the bottom of the cloud becomes negatively charged and the top becomes positively charged. Now, they ask you to give a reason on why the clouds become charged. So you know that charges are produced by friction, right? Charges are produced by friction, rubbing of particles. So that is the answer that you should. That is the answer that you should be going for. Okay. All right. Sorry. Yeah, this is my first time making a video, so please forgive me if I'm making some mistakes along the way. All right. So give a reason why the clouds become charged. So yeah, let's answer this. The clouds become charged because of rubbing of particles. So you can say that this is rubbing of, okay, sorry, this is wrong spelling. Rubbing of particles or friction. So anything that if you mention anything about rubbing particles or friction, you already get 1 mark already. Okay, so that's how you charge something up, by friction. So the ground below the cloud becomes positively charged. Explain why the ground becomes charged. So they give you a hint. You should use the ideas about electron movement in your answer. All right. So the ground below the cloud. Why does it become positively charged? Sorry. Oh, really sorry. Yeah. The bottom of the clouds becomes negatively charged. But why does the ground becomes charged? And again, positively charged. Why does it become so? Why? It is because of electrons in the ground. Okay, so any explanation? Okay, so if you do any explanation that's related to electrons in the ground, or charges like repelling from the surface layers, all right, so you get 1 mark for each of them. All right, okay, so if you do any explanation, again, if you do any explanation which involves there's electrons in the ground and repelling from the surface layers, you should be getting 2 marks. All right, number C, last one. Okay, now the buildup of charge in this cloud and in the ground causes the air to ionize. This means that the air becomes a conductor and a low resistance spark from cloud to the ground is formed. State what is meant by the term ionize. I give you guys a hint, which is use the idea of ions from chemistry. So ionize is creating ions, right? Meaning that we are losing charges. Okay, we're losing electrons. So we're losing electrons for it. So ionize means that lose or gain of electrons, but it's only for electrons in the outermost shell. Okay, lose or gain of electrons in the outermost shell. Now if you can put this in, this 1 mark is for you. And the final one is a 3 marks for you. State the relationship between charge, current, and time. So this is very simple. Charge is equals to current into time. All right, so if you guys want to write the symbol for it, right? Charge is Q, current is I, and T is time. So in exam, if you're not confident that you should be, okay, but if you're not confident that Q is charge, right, you can just write charge is equals to current into time and you'll get 1 mark. But if you try to write instead of Q, right, you wrote a wrong symbol such as C, right, you're going to get marks deducted because the examiner is going to think that, oh, right, well, he knows this equation, but he's actually writing charge as C, so you're going to lose marks unnecessarily. Okay, so unless they mention that write this in symbol or whatsoever, you don't have to write it. Okay, you can just write charge is equals to current into time. If you write something unnecessary and then that unnecessary thing is a mistake, then you're going to lose marks. Alright, so that's it guys for tutorial for walkthrough. This is my first time making a video like this, so if I make any mistakes, please forgive me. And if you have any suggestions on how the video could be improved or the explanation could be improved, I would really appreciate it. Alright, so as you can see, the time is taking about, I'm not sure how it will be on edit the slides, but it would be about 30 minutes. I took around 30 minutes to do this, so if it's for you, you should be taking around an hour, 45 minutes to an hour, right? So you should have around 30 minutes on your hand to double check your answer. And if there are concepts that it's hard for you to explain, you can use those extra minutes to brainstorm, and then think about what the explanation could be. Hope you got. All right, so that's it, and I will see you guys in the next tutorial. All right, bye bye.